All right, welcome back. So what I'm going to do now is I'm going to show you an example that I created. It's not exactly like the ones that you're going to need to do in the lab, but it's very similar. And the tools that I'm going to show you are going to be extremely useful to you for the lab, so make sure you pay attention to this closely. So the goal is, for the problem that I created, is to change 0x1234567 to 0x43215678. So in other words, I'm changing the upper part of the register, okay? So if you understand how move W and move T work, move W populates the lower half and then move T populates the upper half. So you're probably thinking, since I'm changing just the whole entire upper half of the register, couldn't I just use move T to move that new value in? The answer is yes, you absolutely could. But I'm going to show you another way that will allow you to work with other parts of the register. So what I'm going to go ahead and do is go to the whiteboard real quick, and then we'll go ahead and work out the solution on paper, and then we'll go ahead and take this over to code. Alright, so I'm at the whiteboard, and then as you can see here, I have the original value and then the desired value. So I'm going to go ahead and show you a really cool property. And this should make it absolutely no surprise to you because you've already done this kind of thing before. But what would happen if we have a 0x00, keep in mind that we are going to be in hex. Say I was going to OR that with 0xAA. Well, if you go ahead and just walk through this in your head, you don't even have to write it out in the binary form. You know that you have zeros up above, and then you know that you have your bit mask on the bottom. Since you're ORing your bit mask with zeros, the result should just be your bit mask, right? So the reason why this is useful in solving this particular problem above is because what if we go ahead and then we first clear out the upper portion of our register. And then after we clear it out, we OR that with a bit mask that will give the upper half of the register the value that we want. So thinking about that, that should make complete sense, right? Now the reason these are zeros is because 5, 6, 7, 8 doesn't need to change at all. So that's the bit mask that we're going to need in order to do that right there. But before we go ahead and worry about that, let's go ahead and worry about clearing out the upper half of that register first. So going back to the coding environment, we know that since we're clearing out the upper half of the register, the bit mask that we're going to need is going to need all of those upper bits to be ones in order to clear them. The rest are going to be zeros because we don't want to change those. So I'm going to go ahead and use two instructions to do this. You could move your bit mask into a register using move W and move T and then doing it that way if that makes more sense. But I feel like it's good to save registers when you can. So let's go ahead and confirm that this does in fact clear out the upper half of the register. The original value is loaded, the upper half of the register is clear. Now we're ready to go ahead and set those bits. So let me step out of this. And remember, going back to the whiteboard, that's the bit mask we're going to need, okay? So that bit mask, again, you cannot use it as an immediate value because it's too big, but just like I showed you with BitClear, we can do it in 2 steps. So let's go ahead and do that. All right, as you can see here, I went ahead and now set those bits using OR 2 times, using 4, 3, and a bunch of zeros in the first one, and then 0, 0, 2, 1, which if you put those guys together, it's 4, 3, 2, 1, and then zeros. So let's go ahead and run this code and confirm that it does in fact work. Starting from the top, there's the original value. We are going to clear the upper half and then set that upper half to the value that we want.